Hi Lakers, this video is to help you um, understand what to do in Desmos today. So once we join this activity, let me know how you're doing today. And then think about how many 2's do we need to multiply to get 8? How many 5's do we need to multiply to get 625? And if we start multiplying our 2's, we can see that 2 times 2 is 4, times 2 is 8. And so the answer to this question is that we need 3. 3 multiply 3 times. Okay? And then also think about what would it be for 625. When you are ready to see the answer, go to the next slide. And how many 2's do we multiply to get 64? And also, how many 5's to get 25? So now what we're going to do is look for the missing power. So keep going with those ideas. How many 3's do we multiply to get 81? Well, 3 raised to the 4th power, that is 81. And so what we need to do is type just 4, and we'll see that that is correct. Then it's going to get into some negative exponents. This will be -1 because 5 raised to the -1 power is equal to 1 over +5. So -1, this one is actually 1/2. When we take the square root of something, we are raising it to the 1/2 power. And here is that 2 to the 64. We have to multiply 2 by itself 6 times to get 64. And then 10 raised to the 4th power. Notice 1, 2, 3, 4 zeros to get 10,000. Now this one is a tricky one. How many times do we multiply 9 by itself to get 1? That is nothing. Anything to the 0 power is 1. And this is the person that created this activity. They seem to think their superpower is being Batman. But your superpower is finding unknown exponents. Now, here is a picture of a graph of logarithms and an exponential function. All of these pieces are true for inverse functions. We switch the x's and the y's for the inverse. The function will pass a vertical line test, and the inverse passes the horizontal line test. Remember that from our function project? And then the range is the domain of the inverse. They switch. And then to graph the function, we just need to switch the x and the y's and plot a few points. And you'll see that is a great answer. All are true statements about inverses. Here's where we're going to switch our x and our y's. Click on the graph and you can see the x and the y values. So I'm going to remember these two. -2, 0.25, flip it would be 0.25 and -2. And notice once I typed that 2, it plotted the point of the inverse. Keep going. 0.5 was -1. And notice we're creeping up on our graph. And then we had 1 and 0. And then we have 2 and 1. And lastly, 4, actually 2 more. And then the last one is 8 and 3, a flip from 3, 8. And that finishes the curve. And you can see that that is a reflection over this y equals x purple line. In slide 7, there's nothing that we can do to solve this equation in the options that we have. So it's really none of the above. We need logarithms. So please read here. How many times do we multiply 2 by itself to get 8? 2 raised to what power will give us 8? The inverse operation that we will use is called a logarithm. 2 to the x power is equal to 8 is the same as saying log base 2 of 8 is the exponent. And we can see that this exponent is raised to the 3rd power. Here are some more explanations of logarithms, but there's no wood in a logarithm. Here is where we're going to do some calculating of logs. Look for the base. The base is what has an exponent. So this base is 6. Log, shift, underscore to get that 6 as a base, and then arrow to the right to type the 216. And that's equal to x. Now, we know that 6 times 6 times 6 is 216, so the x value is 3. And keep going through these logarithms. Log base 7 of 1 divided by 49. Well, 7 squared is 49. But notice 49 is in the denominator. And so look, that produces -2. So I'm going to erase this -2 now. I'm going to go back in and calculate and leave this equal to x. And then type my -2. Okay, once you complete this table, it will tell you if you are finally correct. And check your answers with the PDF if you get stuck. And then in these next few slides, we're going to practice typing logs. Log, shift 2 of 8, and that is 3. And it'll tell you that it's perfect. Now, another way to do this, if you're tired of typing, you can copy and paste. I just forgot the word log, but notice that once I type that L, I get my answer. Perfect. Keep going through these practices. And then when you get here, this is where we're going to rearrange some things. Notice that the base is not always a number. Like in this case, x is the base, and it's raised to an exponent of 3 to equal 1,000. Well, notice there's 3 zeros, and that means it's 10 to the 3rd power. And if you're hot, it tells you you are correct. And then keep going. 3 raised to the exponent, 1 divided by 2, is equal to x. Well, anything to the 1/2 power is the square root of 3. I am going to finish this table. This will be x to the 5th power equals 243. And that is 3 to the 5th power gives us 243. Okay, here is 5 raised to the x power And that is equal to 1. This is 0.2 is 20%, which is also known as 1/5. And if we look at that in terms of 5 to some power, that's the same as 5 to the negative 1 power. So the exponent is negative 1. Lastly, base 3 raised to the exponent of x equals 3 to the power of 12. And notice the bases are the same, so the exponents have to be the same. So x is 12. Build your confidence by completing this slide, and then practice a little bit more with some challenging values. And then remember this one, log base 4. Log base, oops, shift underscore 4 of 64 is 3. Here is the graph, and I would encourage you to find some nice clean points on the red curve that we can model for its inverse. I'm going to change color. I'm going to go blue. Actually, I'm going to go black for the points. And so this point right here is 0, 1. So that means my point that I plot for the inverse is going to be 1, 0. Okay, and then notice this point right here, that is the point 2, 4. And so that means the point that I plot for the inverse is over 4 up 2. Okay, and the last point that I'm going to use is up here. Those coordinates are 3, 8. And so what I'm going to do is plot 8 and 3. Now, as you start putting a curve into this graph, you will be able to see if you're correct. So this is 8, 3 to this point. Now I'm going to adjust these so the points are near the coordinates. You don't have to be as precise as I am. And then now I'm going to take a color. I'm going to go, let's go purple. And I'm going to go big, big font. And I'm going to draw a curve through my points. And look what came up. When you have finished your sketch, press the button to see the actual graph. And notice the dashed blue line is the y equals x line. All inverse functions and its original function will be reflected over this line. And notice they are symmetrical and have that reflection. So if you get close to that curve that shows up, nice job. Keep moving. In here is where we're going to make a prediction. Use the line tool to line up 200,000 with the x-axis. And we can see that that's at about 122 or so in an estimate. Consider how reliable that would be. 125 months after March of 2011. How realistic is this prediction? Lastly, here's where you need to watch a video. I walk you through how to make a prediction of time. I ask the question, when as in what month will the value be worth $200 billion? That's the same as 200,000 million. So please watch this video as I walk you through in my notebook how to solve with logs. And then here is the images for how we find logs in Desmos. I also show you how to do this in the video that you're going to watch in slide 20. In 22, please share your confidence. Again, screens 23 through 31 are optional. And if you get stuck, look at the PDF. Here are special logarithms. Logarithms with base 10 and logarithms with base E. E is a value that we see a lot in science and in mathematics. It's a common base. It's a natural base. Here we are looking at how we can rewrite expressions as simplified, and you will be told if it's correct. Here looks at how does the domain and the range relate between exponential functions and logs. Here's how we can adjust our graph. How does a log graph change with its base? Here, I would encourage you to challenge yourself, think about how we can write equations, and if you get stuck, go to the PDF, write the correct equation to build your confidence. One more graph to match, and then another challenge using a natural log. Here is a card sort, and every card will be used once. Check your answers in the PDF if you get stuck. Thanks for watching the video.